What's going on, everybody? Welcome back to the channel. Today is Sunday, December 1st, 2024 at approximately 3:30 p.m. and I appreciate you joining me today. Whether you stumbled upon this video as a subscriber, a YouTube search, or if YouTube's algorithm gave you a little bit of a nudge, certainly appreciate you being here. Wherever you may be, whatever day and time you may be watching, I hope that you're having a great day. I know that I certainly am because I get to share this video with you all today. Today we're going to be taking a look at building a Revit family for mechanical equipment. This is going to include all your necessary connections, including supply air, return air, hot water coil hookups, refrigeration hookups, condensate hookups, and clearance zones, and how to make it customizable to fit your needs. You can go download some of these mechanical families from the manufacturer, but two things. One, I think they have entirely too much information in them. And two, I like having my own families built for different types of equipment, having them loaded in my template, and that way I have very easy access to equipment, and all I've got to do is pull up the submittal and change the size of everything as needed based on the submittal that I'm using, whether I'm on the engineering side and scheduling it. And with that, the way we build this family is going to help with scheduling if you like to automate your equipment scheduling within Revit, or if you would like to go that route. It makes everything so much easier. Might as well utilize what Revit has to offer, and I can do another video detailed video based on scheduling. Anyway, thanks for stopping by. If you find this video helpful, please don't forget to like and subscribe. It really helps out with the YouTube algorithms and helps me get some views on here. It helps me keep creating some videos for you guys. Anyway, enough rambling. Let's go ahead and jump right on in. I'm going to go to Families and then New. And a lot of times, a lot of people taught me, oh, just do generic and then adjust it from there. In this case, I'm going to go to Mechanical because it's got some features in there that I already want preloaded. You can do ceiling based, should you be working on a cassette ceiling mounted mini split, or an exhaust fan, or you can do wall based if you're doing a high wall mounted mini split or any other wall based equipment. I'm just going to be selecting the mechanical equipment template here, open. And it's going to bring us to this screen here, and I'm going to be drawing in a simple Airmark low profile fan coil unit that I use quite a bit. And here's my submittal. I'm going to be drawing this GFT 18, and I'm going to show you how I easily set up these other ones as well. So that's the dimensions I'm going to be using, and I'm going to pull it on my other screen so that I can do both at one time. I went to create, clicked on extrusion, and now we got to get back to modify and create, and I'm just going to draw a box. And this is our plan view, so we're from the top looking down, and I'm just going to draw a box, and I'm going to set my dimensions from there. The width of this bad boy, the A dimension, is 46 inches. The depth of this thing is 24 inches. Oops. 24 inches, not 24 feet. Revit defaults to feet, and so you have to specify inches if you're doing inches. If you want to do feet, all you got to do is type 2, enter, or however many you want. But anyway, there's our box, and we are going to set our height of 11 inches. And now we're just going to click that green button and say OK. We're going to click close inactive views, and then we're going to open up the 3D view. We're going to look at both of these at the same time, or we're going to use both of them. Now you can see we've got just a basic little box here. This is our box for our, in this case, fan coil unit. Now what I'm going to do is go to a front elevation, and I'm going to draw my supply air. So let's go back to create, extrusion. And I can set my work plane, pick a plane, okay, and I want it to be right there. Now, that's my start. So I'm going to go, it looks like it's about 2 inches deep, it doesn't actually give me a dimension, but I'm going to say 2, and I'm actually going to go -2 so that it pulls it forward. And I'm going to go ahead and draw my square. And a minute ago you saw I drew a box and adjusted it. You can also just look at your dimensions as you're drawing it and set it. This is 7 inches tall, so I can go 7 inches tall, and I am on the supply side, which is B, which is 30 inches. So there, and then we want to make sure that that is centered, so I'm just going to do LI, draw a line across, and then set that right there, get rid of that line. And now you can see, well, I guess it did recess it. I want that to be the other way, so I can change that negative, boom, just that easily, and now it goes forward. Okay, now you can see we've got what I'm calling our supply air side, so let's go ahead and add a connector to that, duct connector, and we are going to select that plane. And you're going to hear me complain a lot about Revit. One thing is when you add that duct connector, I mean, for me, 27 out of 27 times, I'm going to be selecting something I want it to be the same exact size. Why Revit just defaults to some weird 1x1 blows my mind. But anyway, rant over. You have to come over here and change your size. So my height, I believe, was 7 inches, and I believe my length was 30 inches. Boom. Now I've got a connector on there, and now let's go ahead and make sure we get all of this situated correctly. It's not bidirectional, it's out. It is supply air. I'm going to put a loss method in here and say specific loss, and it gives me, in my submittal I've got here, it tells me I've got a 0.4 inch static loss. I'm getting 1195 CFM, and that's how this particular one was selected, so that's how I'm going to set this up. You can set that however your selection is. I just like to have all my information in there. All right, cool. That's our supply side. Easy enough. Let's go to the back side, and let's do our return. Actually, an easy way to do this is actually just select that, mirror, flip it like that, and then I can actually just do it from right here. Because the difference is, I believe the length is different. 7 inches is the same, but it needs to be C dimension of 34 inches. There we go. And I guess the problem here is that now it's not really going to be centered. And we can say okay, but we can always go to our back view. Back, it's that one, and we can just move it very easily. All right, now we want to add go to create, connectors, duct connector, and we want to create a return air duct connector. Our height is the same, it's 7 inches. Our width, I believe I said 34 inches. Yep. And there you have it. And now we got to make sure that we fix our mechanical flow here. We got, that's going to become an N. That's going to be our return air. I'm not going to do, we could do a loss method here, specific loss method. It's going to be the same, and 1195. Okay, now we've got our supply air side. We've got our fan coil, that's the size we need it to be, and we've got our return air side. Now let's go in and add some of our connections for hot water and condensate and refrigeration. I'm going to do mine from the reference level to show you guys a different way of drawing in different extrusions or different forms, I guess. This one we're going to do a revolve, and I'm going to do it by line. Could do it either way. I can do this, but point is I'm going to do, they don't tell me exactly where they are, so we're just going to kind of arbitrarily locate them. This is the supply side. On the left side with the air to my head, I want my hot water on this side. We're going to come out 2 inches, and that is a 7/8 of an inch. which is 7/16 is half of it. So there we go. And now we have to click axis line to give it something to rotate around. So click our axis line and we'll draw that in right there. And we'll just click done. And now you can see we've got a connection for our hot water coil. Or we have a piece that we're going to add a connector to. So now let's go to our right side view. And I'm just going to arbitrarily place these. If your submittal shows it, put it there. Check with whomever if you need to. But for purposes of this video, I'm just going to make it quick and locate it. And we're going to go to create. These are going to be pipe connectors. And we're going to select that. And again, I mean, it's giving it a 2-foot diameter. Why it wouldn't give it that diameter? But anyway, so we want a diameter of 7/8 of an inch. And then we're going to do the same thing with this one. Oh, actually we have to make sure we have everything correct. This is going to be, let's just say this is our supply. And I'm not going to worry about that. It's not domestic hot water. It is hydronic supply. Flow GPM, I actually do know what that is. And we're going to put that in. My GPM, we're going to call it 2. Right in the middle of the road of what my submittal is showing here. So we got 2 GPM. And now we're going to add a pipe connector for the other one. Pipe connector. Again, we got a damn 2-foot radius, as if I ever need a 2-foot radius pipe connector. 7/8 of an inch. Again, I do that quite often. 7/8 of an inch. Okay, now we want to change this one to out because this is going to be our return line. GPM dose. All right, not too worried about anything else. Now let's do the condensate on the same side. Again, make sure you always double check your submittals and draw everything exactly how your submittal shows, no matter what side you're on. If you're on the engineering or BIM 3D modeling side, please make sure you put in the right stuff, because if you're doing on the engineering side, it makes everything work out better on the construction side and eliminates a lot of the RFIs that we get on the engineering side. Create, we're going to do another revolve, and we are going to do, we're going to make it a 1 inch. Again, it doesn't tell me. We're going to come out 2 inches, and we're going to make it a 1 inch diameter. And we are going to select axis line again and draw it and click OK. Now you can see right here we can do move up. Let's just now we're going back to create pipe connector, select, did not add it. Let's see, create pipe connector. Let's see if he'll do it from this side. That's weird. I don't know that I've ever had that happen before. Is it putting it on the inside? No, it's not. Let's try redrawing it. I'm not sure what happened there. Let's do revolve. We're going to come out 2 inches. It's going to be 1/2 inch. Boom. Access line here. Boom. Now we should be able to move that up. Create pipe connector. Create pipe connector. There we go. It was selecting the whole thing for some reason, so I had to hit tab. Let me undo and show you what happened there. I like when these things happen because sometimes you might have these problems as well. What was happening was I went to pipe connector, and you can see it's selecting the, I'm pointing as if you can see, but it's selecting the front blue line and the back one. I had to hit tab and then select it. So again, we got a 2 foot for whatever strange reason. 1 inch is all we need. And this is going to be not bi-directional, it's going to be out. And there's not a condensate in here, I don't think. Let's just put it under, I don't know, sanitary. You can put it under other or sanitary, or you can probably even create a new one for condensate if you want to. But all right, there's our connections for that. The other side, we're gonna need connections for our refrigeration line. So let's go to create, revolve. And again, it doesn't tell us where to put these, but we're gonna come out 2 inches, and our suction line is 3/4, so that's 3/8. There's half of that. Access line, boom, and then we need to go to the left side, and then I'm just going to arbitrarily place this. My condensate is definitely not going to be that high. Move that down. Okay, here let's just say they're pretty close to that. And then let's not copy because they're two different sizes. So let's go back and create a revolve, draw a line out 2 inches, and that is 3/8, which is 3/16. Is half of that. Boom, and access line right there. And now we go back to our left side. We're just going to put up kind of close to each other like that. Now we go back to, now what we need are connectors on those. So we're going to go to create, pipe connector, select on that, and we're going to change that one to, I think that was 3/4. Is that mine? Suction line. All right, so now we're going to say out. And this is, I don't think refrigeration's in here. Again, you can go set it up. I'm just going to do hydronic return, but you can go in there and set up refrigeration, liquid, and suction lines. But for purpose of this video, I'm just going to select hydronic return. And we need one for the other one, create, pipe connector, boom. And that one was 3/8. Right? Yep. Always double check. Always double check. I think I'm calling this in, so we'll call this supply. Again, go in there and set up a pipe system for refrigeration, suction, and liquid. I'm just going to do this just to make this video quicker. But anyway, hydronic supply, apply. Awesome. Now we've got everything. All of our connectors are good to go, and we are in business. So the next thing we want to take a look at is setting up our reference planes and getting some parameters built in so that we can adjust our sizes for the different model numbers and different sizes for those model numbers in there. So let's start with a front view actually, and pull it on this side. And let's just kind of start building this. So I'm doing RP for reference plane. And I'm not going to name them. You can name them if you'd like. Just, again, to make this as quick as possible. It's already kind of going long, but want to make it as detailed as possible. Anyway, so we've got reference planes here for our width. We're going to do RP for a reference plane set for the height. And we'll come back to some of the other ones. So what you have to do is, this is my reference plane for the height, so I need to select that. I did align AL, select my reference plane, select my line here, and lock it. And I do that for everything that I just drew. Select the reference plane, align, lock. Reference plane, align it, lock it. So now what we can do is start kind of building this thing out. So we want this to be equal so that when we adjust the size of it, it goes both ways and doesn't just go one way or the other. So we want to set that to equal. And then we want to set, now we've got a dimension for our overall width. And what we have to do is create a parameter for this so that we can adjust it. So we're going to come in here and create parameter. It's going to be a type, and I'll show you why. And this is going to be our width. And common length and dimensions is good. And okay. Now, just real quick, you can see if I change that. Now if I come into family types and my parameters are listed here, I've got width in here now. And if I change this to, I don't know, 5, you can see it goes out both ways there. And you see it took this with it, but we're going to fix that as we move along here. All right, so let's undo that. And now let's do the same thing for our height. And then we're going to have to create a parameter. Height. Everything looks good. And boom, now we've got width and height parameters that we can come in and change as we please. Now now you can see if I change this width there, I can change it here too. If I change this width here to 5 feet, it automatically is going to go ahead and move those pipes that we created right there. It's going to go ahead and move it with it. But the further we get along, you'll see that we're going to have to create something else to get that to kind of lock in place. So next, we are looking at it from the front, so let's do our supply. So what we have to do is create a reference plane for the width of our supply. And we have to do the same thing. We have to go with the equal, and then we want to do a dimension and new parameter, and we're going to call this supply air width. Okay, and now if I need to change that to, I don't know, 36 inches. Now you can see it moved it out both ways from the center line, out both ways, because we put that equal in there. One thing we forgot to do here actually was align. So we got to click there. We had to tab and then select and lock. Select, tab, lock. Now, when we move that to 3 feet 6, our offset, our flange, if you will, moves with it. And I believe you have to manually adjust the connection size when you do that. All right, so now let's do our supply air height. So we got to do a reference plane for that, RP. Reference plane there. Let's just select and copy it down. And then we need to get a center line here across our unit, so we know where the center line is, because we want everything to be equal. Now we're going to do DI, and that's going to be equal. And we need to do same thing here. We got to align and lock, align and lock. And now we can do a dimension here, 7 inches, and then we'll call that supply air height. Okay. Now when we change this, let's say that this on a different model is 8 inches. Now we need to do actually DI from here is equal. And then we need to do DI here is equal. And I'm going to change the scale so I can see it better. Let's change it to 1.5 inches. All right. Now we can see a little bit better. Now it should move in both directions instead of just one way. 8 inch. There it goes. All right, so now we have our supply air height, we have our supply air width, and we can see that everything is kind of moving together. Okay. Now let's go to the back elevation, and let's do our return air. So reference plane, reference plane. And same thing, we want to do the equal thing, or we got to align. Boom. Had a tab there, align. Boom. Got a tab, align, and then lock. And then we'll do, oops, come across and say equal. And then above that, we're going to have our width. And let's go create a new parameter for return width. Okay. And we're going to have one for our return air height. Oh, some new ones on this side, reference plane. And again, you can name these just for purposes of being quick. I'm not going to align to that. The return, align, turn and lock it, return and lock it. And now we should be able to do equal for this. And now we should be able to do that. And then did I do return width already? Return height is what we need. So let's go create a new parameter for return height. And now when we change this, let's just say it changes to 8. Now you can see it moves both ways properly. So now we've got a fully customizable piece of equipment here. We've got a little fan coil air Max. Air mark, excuse me. Got a little air mark fan coil unit here that is fully customizable in terms of sizing. And so the next thing we're going to do is let's add in some parameters if we want to get them scheduled. I'm only going to do a couple to keep this brief, but you can add as many as you want. I think I have something pulled up here. Yeah, so you know, here's a schedule of mine. I'm just going to kind of go through some of these: supply air, outside air, and some other things, but you can add as many parameters as you would like if you want to automate your schedule. So let's just start here with supply air. The supply air is going to be HVAC, airflow, and it's going to be under mechanical flow. And it is going to be a type, because I'm going to change each different type, and I'm going to show you here in just a second how I'm going to do that. So airflow, blah, 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 good to go. And on this particular one, I think it was 1195. Apply. Oh, let me show you something real quick while I'm thinking about it. You can assign an airflow to your connector as well. Oh, I did show you. Okay, so we can also do that and make it part of our schedule as well. So let's get back into here. Supply air we have. Let's get in some outside air. I'm going to bounce around a little bit just to give you an idea. HVAC, airflow, mechanical flow. And let's just say our outside airflow is 200. I have no idea. Just throwing stuff out there. All right. Now let's say next we need our RPM. So we're going to go to new, and we're going to call it RPM. That's going to be under HVAC and an angular speed. And we are going to make this usually the RPM I have under the supply fan. So let's just put it under mechanical. Okay. Now we can put our RPM in here. I don't remember what this one was, but look at your submittal and whatever your RPM is. And as we do this, I'm just going to go ahead and say my type here is my GFT. What was it? GFT 18. We're building a GFT 18 right here. Excuse me. Let's rename. Let's rename it to Airmark GFT 18. Okay. And We can set a default elevation. It's never going to be 0. I mean, 9 is probably about as standard as it gets. Let's add, I don't know, let's see, let's add one more. Let's add our total capacity. So let's say cooling capacity. That's HVAC, and it's a cooling load, and it can go under mechanical. You can put it wherever you want to. I'm going to put mine under mechanical, just because I want everything right there, and then I can get it scheduled, no problem. BTUs on this one, I don't know. What's that? Okay. All right. So now, again, add as many parameters as you need in here as you want to have on your schedule. You know, I've got my cooling section, heating section, electrical section, weight, and I've got a little notes section for any comments that I may want to add in there. And then what we can do, I'm just going to do one more real quick for you. So let's just say we want to make an Airmark GFT. Let's do the 1924. 1924 right here. And what I'm going to do is say new, and we're going to call it the Airmark GFT 19 to 24. Okay. Now, my height stays the same on that, but the dimensions that change are going to be my A, B, and C dimension, which is going to be my supply air width is going to change to, let's see, our B dimension is 36. Our overall width on the model is going to change to 52 inches. The height of our connections is going to stay the same. For supply and return is both going to stay 7-inch. And let's just say the airflow changes to 36. I'm not looking at it. Let's say the air, I'm not looking at it. Let's just say the airflow on this one goes to, I don't know, 3,000. And our outside air is now 600. I don't know. So now I've created an Airmark GFT 19 through 24. And you saw down below everything's changing. If I select 18, it'll all change back. Let me move this to the other screen. There's my GFT 18. If I click on GFT 19 and apply, you'll see it changes my sizes. And everything goes with the return width, supply width, and everything changes with it. I can add that as many times as I want, and when I load that into a project, which I don't have any open, but once I load that into the project, I can very easily select between the different models that I want. Let's go ahead and just open a project. I'll stop talking and speed through this part and show you just loading something in. All right, so now I've got my fan coil unit loaded into one of my projects, and I'm going to type ME, and you'll see it came in with the 19 to 24. It's also got the 18 right here. Whatever we set up in there, it's going to show up, so you can set up as many as you want. You can see it says family 4. That's because I didn't save the family that I created, but I'll show you here in a second. What I typically do is we'll name the family file, whatever the manufacturer is, and then right here I'll have GFT 18 or whatever the model number is, and that helps with the scheduling aspect. Anyway, let's go ahead and place this in. You can see it's already set up to our default elevation that we put in, and let's just go ahead and put that in. And you can see you got your GF 18. I can easily select my 19 or whatever other ones I have in there. And let me show you something real quick. There's a couple of things that I did not show you. One, if we click on this, the duct size actually isn't the correct size here. I mentioned earlier that you can't lock the connectors, but there's another way to do it that I was blanking at the time. So let me show you how to do that real quick. If we come over, this is our family. We're going to do 3 things real quick. This is our return side. It says right here, return. What we have to do is right here under dimensions, to get that to move with our extrusion, we want to assign a parameter to that. So that's going to be the return height, and this is going to be your return width. Okay, and we're going to do the same thing over here. That's going to be the supply side, so that's going to be our supply air height, and we're going to have right here our supply air width. And so now that's going to move with our extrusion. Now, the other thing I mentioned earlier that I was going to show you and forgot to was how to put clearances in. Please use clearances whether you're an engineer, certainly on the 3D modeling side, because we have to make sure that nothing's going to be in our way. And if you do this on the engineering side, it just helps you avoid any future problems or RFIs. I happen to work on both sides, so I just know that it makes it easier for everybody if on the engineering side you have these clearances in as well. Really quickly, I don't know what the clearances are on this, and I'm not going to bore you with it, but I'm just going to draw a line. You can set up a line type for clearances. I'm just going to do hidden lines for this one. I only want this showing up in the plan view, so I'm going to come over here to visibility and graphics override, and I'm going to deselect front, back, left, and right. And there we have our clearance that's going to show up in plan view. You're going to want to create reference planes and lock it so that the clearance is going to move with the width and everything and all the other dimensions that come along with it. So that's what we'll see in plan view. And we also want to, for purposes of 3D modeling and coordinating and clash detection, we want to make sure we have a box there. So we're going to go select extrusion, and we're going to do a rectangle, and let's just say that this thing goes, you know, down to the ground or something, so that we make sure nothing's below. So we want to make sure we have plenty of room, that nobody's going to impede in that space, and that it'll show up in the clash detection. In worst case scenario, we can always, you know, take a look at it on a case by case basis. But now let's do our extrusion in. Now let's just say that it's something to do 1 foot, apply, and now let's draw our box in. All right, now we've got an extrusion. Now what we want to do is category. I went ahead and created this clearance right here. We want to change the appearance. I always do mine red because it's basically saying, hey, this is a no-go zone. I do a transparency so it doesn't show up. And you can see your equipment behind it. Apply. Okay. And then if we click that, now if we go to a 3D view, you can see we've got our clearance. We got a couple of inches above on the side, and this goes all the way below. Now when I run a clash detection, if anything comes into this space, it's going to show up in that clash detection as a clearance. You can also, if you want to, add a parameter to it, but this is how I would do it. Now let's load this back, or let's do, first thing I'm going to do is show you real quick. If I'm going to do save as, family, and I'm just going to save it right here, air mark, options, always change this to 1, save, yes. Now let's load this back into our project. And now you can see, one thing I forgot to do, let's come back to our family, select on your box here, visibility overrides. We don't want to see that in a plan view. We only want to see it in 3D. So we're going to actually deselect it from everything. Okay. And we have to, we don't necessarily have to save it, but load into project and overwrite. Now we only see the line for the clearance. And now there's our 18 that actually showing our size of 30 by 7 because we added that parameter. And now I want to change this to 19 to 24, 36 by 7 is the correct size. And so now it puts that in there correctly. Anyway, oh, now you can see also right here where it says air mark. So if I go to do a schedule, I can do a schedule and do it by family name, I think it's called. And then you can actually rename that to say model. And then this bottom part here, you can have another column for that for the model number. And that's kind of where those items come in handy. And let's say that you get in here and you realize that you need to add a 30, a 36. All you have to do is duplicate, call it 36, okay? And then you can come in here and manipulate your all the information that you have loaded in there. Anyway, hope this was helpful for somebody, and hope you guys got some use out of it. Please don't forget to like and subscribe, and we'll keep bringing some videos at you. Thank you, and have a great day.